Alright, I want to do a little video on how some of these meters compare to each other on certain functions. And this function here, I've got 4 of these leads in a glass of water that's acclimated to room temperature for about 5 hours. And I've got them all kind of tied together. I've got the ST4 field piece, the AMP320 by Amprobe, a 116 by Fluke, and the HS36 by Fieldpiece. So you can see the Fieldpiece is 62.4, the ST4, and the Fluke is 62.7. They're about 3/10 apart. Now the Amprobe is 61.8, and the Fieldpiece HS36 61.7. So they're about a degree's difference between this one and this one compared to these two. So on temperature, the Amprobe is comparable to the HS36. The ST4 is comparable to the Fluke 116. Next we're going to test capacitance. It's not far off. Let's get the Amprobe. .0, 7.1. Now you got the field piece. The one thing I got to say about the field piece, what I do like, is the cables. I don't know, they stay supple. They don't feel, even when they're cold and stuff, they don't feel as stiff as the Fluke or the Amprobe cables. So I kind of like those. Kind of like that feature. .2. So I'd say they're both they're very comparable. And the good thing proven here is, if you ever get an amp clamp, it's hard to get an amp clamp that actually, you got to watch, especially the Fluke amp clamps. I got stung by it before, didn't realize it. I went to check it with a Fluke amp meter, and I can't remember what model, and it had capacitance and all that, and I was really stoked about it. And I went to check the capacitor like this one here, and it read 0. Thought it was bad. Got a new one out, checked it, it was 0. Thought, wait a minute, something's wrong here. So I got looking at the documentation on the meter, and at anything below 10 microfarad, it wouldn't read. It'd go down to about 9, and then it would just read 0. So here, with this guy here, you do get the functionality of the amp clamp. And you know, this here doesn't feel super cheap, but for the price of what this one costs compared to a Fluke, and the fact that it'll do the microfarad to the real small low amounts. So I will do these two guys and have them compare their amp readings. It's going to be low amp stuff, so we'll get to use the wire here, because this is for less than 60 amps, nothing more than that. And the one thing I can tell you now, the non-contact voltage function on both of these, you push the button on this one, go to your spot and see what it reads, You don't even have to have it on. You can turn it off. This one, you turn it to non-contact voltage. Right there, NCV, and it'll read EF on the screen. Hit select till you see EF on the screen. Now you're in non-contact voltage mode. And what you're going to want to do is you're going to want to get the wire, your source right here, and then it'll show like 1 bar for real low volts. It'll show 2 bars for like 55 volts. It'll show 3 bars for 110. As you can see, just off my finger, this one's going off. This one's not as sensitive. So this one's a little more sensitive. This one right here. So let's see what they do on a light switch and wiring in the wall. Okay, as you can see, this one gets sensitive when you get close to an electric source. It's already pegging 1. Then getting close to the lamp. Now right now it's already detecting 110 volts. It's very sensitive. I don't know if that's a good thing or not. If you're trying to check a wire, let's say a specific wire in a cluster of wires, and some of them are dead and some aren't, this may not really pinpoint them for you. And you got the red light. Makes the noise once you start hearing, once it gets close to voltage. So see, it's pretty sensitive too. I think the fluorescent light is actually causing that to go off. See that light? You hear it. I'm not touching the wall. Just going around. See if I find anything. Okay. Slow and go. Down to the 20 volt range. 55, 110. Higher voltage right there. Getting lower. So it acts like that wire runs up about there. On the other side of this wall there is a light switch. So there's wire going up this way. As we get farther away, like I'm coming down, there's a plug. Fired up down here. Starting to have a little more respect for these guys being so sensitive, because I think they're actually finding wiring that I didn't even know was up in the ceiling. So that's my take on it, guys. Chew on it, digest it, and decide what you want. But a little information on the non-contact voltage feature, capacitance, how close they are all together, the temperature, how close these are, and the standalone dual temperature from Fieldpiece. And I will do some more on some amps, on the amp clamp feature on this one and this one later. Alright, now I'm going to test the amp feature on the HS36 and the amp 320, and I'm going to use this heater here as my source. First we're going to turn the heater on to low. Make sure it's calling. This is the HS36. Got a reading of 4.6. First I'm going to use it as a normal, like in the center between the range. 4.76. Now I'm going to use the feature of the wire, small conductor. 4.79, 4.8. Now I'm going to turn on medium. Seven 7.0. .2. Now we'll use the little tip feature there. 7.27. Now we'll put it on high. 11.83 on the tip. 11.7. That's going up to 11.83 in the field. And the HS36. 11.4. Now I'm going to try this on a different. That's about the same. Now here's one of the other functions that this guy has, is the measures your hertz. So to get to that, you go to your first. They actually, it looks like they both do it. They both say hertz. You hit select till the hertz comes up. Got the heater calling. There you go. 60.06. Measures it no matter where you're at in the jaw. So there is another cool function, is the hertz. So if you're ever trying to measure the frequency that an inverter compressor is running, this might be helpful for you on the hertz, because it actually increases the hertz in order to get more capacity out of those inverter compressors. It converts, you got an inverter board that takes the AC voltage, converts it to DC, and then back to AC, to where the AC can actually be cranked up, the hertz can be cranked up and modulated. You obviously can't, nothing can be done with the power coming in, but it takes the power, reconverts it back to DC, back to AC, to where it can increase the hertz to get your inverter compressor to get more capacity for heat pumps. So that's a neat little feature this has that none of my other meters have. Alright, now what I'm going to do is I'm going to use, on this meter here is the only one that can do it out of ones I have. It's got the peak, the inrush current. So I'm going to check the inrush current on this heater. I'm going to turn it on to low and see how it works. Anytime you're using any of the amp features on this, you want to, it tells you in the manual, don't have any leads hooked up. And make sure you keep your hands behind the tactile barrier, not up in here. You need to keep them back here. So to get into inrush current on this model, you have to go to any amp feature, and then you have to hold the record button for 1 second. In other words, you hold it down, and then peak RMS comes up. Okay, there's nothing on there. Turn it on. 483, 4.83 is the peak inrush current. Okay, max. Go ahead and turn it off. Get my amp clamp on there. Now I'm going to turn it on. and see it showed 4.79, and it just shows as the amperage goes up it will keep peaking up until it stops. So we'll turn that off. We'll turn the peak RMS back on, turn off the heater, get the amp clamp in there properly, turn the heater on. 4.84 was the peak inrush current. So this will show you a higher current than just your max. So if you want to see like a startup of a compressor or any electrical equipment like that, and you really want to know what the top is, this inrush current does show you a higher reading and a more truer reading than your max. So that is another neat feature of this meter. Here's my overview of the 3 meters I've had in this video. The Fluke 116, you have voltage and you have hertz using the test leads. You have DC volts, millivolts, ohms, continuity beep, capacitance, diode testing, temperature, microamps, got backlight, hold function, min max. It's a good little meter. Can't remember what I paid for this, but it wasn't real expensive. You've got the AMP 320 from Amprobe. This one has 3-phase function for motor rotation. You have non-contact voltage detector that uses electrical field to detect voltage. You have precise amp feature. Then you've got your larger conductor amp, because of the precise is for less than 60 amps. This is for up to 600 AC/DC voltage. Continuity beep, ohm testing, diode testing. You have temperature and capacitance. You've got microamps, and here's your phase rotation. I like the hertz on this one better because it uses, you just put it around a wire and it gives you the hertz. The hertz feature on this for me would be good because when using inverter compressors, they take 60 hertz power coming in, convert it to DC, and then convert it back to AC voltage that can be manipulated, and it takes that voltage and it can ramp it up. I believe, and this is a guess here, I think it goes up to like 250 hertz, maybe even higher than that. But it allows your compressors, instead of being a standard 1725 RPM, they can really crank them up there to get your capacity for heat pump. But I like the fact that this uses the amp clamp instead of the leads like the field piece and the Fluke do. The Fluke and the field piece, you have to actually get on both sides of the load and check it that way. This seems to be more reliable and quicker, a lot quicker. On the field piece, you have your continuity beep, your voltage DC, it gives you your millivolts, your microfarad, your temperature, your microamps, your ohms, your hertz, and then you've got your voltage AC, and also your amp clamp function is right here. You also have, when you use your temperature, you've got the thermocouple port here. You've also got the head up here, the accessory heads. You can take these off and you can put the different accessory heads on there. So that is a plus for some people. If you want to expand your arsenal, you can also buy some more field piece accessory heads to go onto this stick meter. You also have the non-contact voltage, which uses the electrical field concept as well. My thoughts on the non-contact voltage: it's good just to detect voltage in the area. If you really want to detect a wire, single out a wire if it's got voltage or not, I suggest using a Fluke 1AC 2A1 little pocket meter. It does like 90 volts to 1,000 volts. And then for low voltage, they've got one that does 20 to 90, and it's a 1LAC 2A. Those are both good little meters, and I highly recommend those. I find them to be a little more accurate to pinpoint a wire. So that is my overview. Price is an issue. This is the guy to go with right here. He's $167, tooldiscounter.com. I don't know what this one cost. I want to say probably around probably around $200. This one here, $199 at TruTech Tools. Local supply houses will probably have these two. The only supply house I have around my area in St. Louis that carries these that I know of is Train. But this is a good one you can buy online. So if you're starting out, you may want to try something like this. If you're doing light industrial or light commercial and you're using 3-phase and you're on a limited budget, I would get this one. If you're doing mainly residential, you don't see any 3-phase at all, and if you only see it every now and then, I like this one for the expandability of this, the accessory heads, and for its capabilities. And if you're a fluke person, you're just determined to go with fluke, this is a good introductory meter. The 116, good for HVAC. It does, like I said, it does. The only thing it doesn't have, you can't do amp draw. So that's the limit of this one. And a lot of the lower priced amp meter clamps that Fluke makes, when you get to the cheaper ones around $200 or $250, a lot of them don't have the range below 10 microfarad to check your capacitors. You get up into higher dollar and you go to a 902, they will go down pretty low, but you have to spend the more money for their amp clamp to actually have a good low capacitance range. So that is my overview of the Amprobe AMP320 and some of its competitors, and I hope this video has been helpful. Thanks for watching, guys.